Hello, crew. Okay, we are working on lesson 40 for simplifying radical expressions. I'm just going to work through the examples with you and write some notes as we go along. So it starts off in example 1 and asks for the fifth root of negative 32. When I look at that fifth root, I want to think about the fifth powers that I know. So like 1 to the fifth is 1, 2 to the fifth, if I actually figured that on my calculator, or you could do it in your head, that's going to be 32. So if 2 to the fifth is 32, the inverse of that, fifth rooting, is going to be 2. Since it's a fifth root, since it's odd, we can have this negative in here. It just means that my answer is negative as well. It means that there are 5 negative 2's. If I multiply 5 negative 2's together, I'll get negative 32. Okay? So the second one is the cube root of 27. Well, again, if I go through my perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is, 27. So my answer is 3. Okay? 3 cubed is 27, so the cube root of 27 is 3. Last one is the fourth root of 16. So again, I'm thinking, what are my fourth perfect powers? Okay, my perfect fourths. So 1 to the fourth is 1. 2 to the fourth, that's 16. So if 2 to the fourth is 16, then the fourth root of 16 is 2. Now, I just want to remind you, when we're talking about negatives, odd roots can be positive or negative, okay? But remember, even roots, I guess I should say I'm talking about inside here. Okay, so inside odd roots, you can have plus or negative. Okay, inside even roots, you have to be negative. All right? Okay, so then what you get, you'll follow the sign. So meaning like here, the fifth root of negative 32 is negative 2. If it would have been the fifth root of positive 32, it would have been positive 2. Okay? When you're solving with even roots, not so much today, but if you're solving, if you're trying to find x, whoops, this should be positive, silly. Okay? Your answer will be plus or minus. Because just like this one, 2 to the fourth would have been 16, but negative 2 to the fourth is also 16. So actually, when you're taking the root of those, the actual answer for solving would be plus or minus 2. But when they talk about principal square root, that's where they're just using the positive. So the only time you're going to have to worry about this guy is if you're solving. And we're going to do that later on in the year. Okay? All right? Now, example 2 pushes this a little bit further because they're not going to give us these perfect powers. Here we could do our perfect fifths, our perfect thirds, our perfect fourths, and we could find these numbers inside, okay? But now we're going to have some that don't. So on example 2, it gives us the square root of 8 times the square root of 5, okay? Now, I could go ahead and try to simplify both of those separately, or I could just go ahead and multiply them together, and now try to find the square root of 40. There's 2 ways to do this. You can either use perfect powers, okay, in this case a perfect square, or you can use tree method. Now, I know the perfect squares of from 1 to 15, actually probably from 1 to 17. So when I look at this, I say, oh, the biggest square that could come out is 4, and 40 divided by 4 is 10, and I know the square root of 4 is 2, so this would be 2 square root of 10. That's one way of doing it, okay? But if you're not so versed in those square numbers, or maybe that makes you nervous to have to think of that, you could use what we call the tree method. And with the tree method, you're just taking the smallest number that'll come out, smallest number that'll come out, smallest number that'll come out, until you get to a prime number. This is when you know you're done, okay? Then I look back at that index. Remember, this was a square root. That means there was a 2 there, even if I can't see it. So I'm looking for partners. These guys can be partners. There is not another 2, and there's not another 5, okay? So what this means is that there's a perfect square right here. So one set of 2's gets to come out front. Remember, this 2 represents this partnership, okay? And then 2 times 5, since they didn't have partners, they have to stay inside. There's my final answer, okay? Now, like I said, if I'm working with square root, I know a lot of those, I can do that mental math in my head. A lot of times I'll use perfect square method. But when we get into cubes and fourths and fifths and sixths and so on, I use tree method more, okay? And I'll show that on the cube root of 54, which is the next one. Okay? So again, when I think of cube root of 54 and I'm going through my cubes, I could think, well, does 8 come out? Does 27 come out? Does 64 come out? Well, I know 64 is too big, so that wouldn't work, okay? But maybe I can't do that division very well, okay? So I'm going to go right to tree method. And I'm going to say, what's the smallest number that will come out of 54? 2. Gives me 27. Spoiler alert, there was your perfect cubed. Okay? Smallest number that will come out of 27, 3. Gives me 9. Smallest number is 3. Gives me 3. I'm prime. That's how I know I'm done. Then remember, this is a cube root, so I'm looking for groups of 3 this time. Well, there's a group of 3 right here. Okay? So that means their 3 has to come out front. Remember, this 3 represents this group of 3. This guy did not have a partner. He has to stay inside. Okay? Again, I could have done that same thing if I recognized that 27, a perfect cube, came out. I could have said 27 and the cube root of 2, cube root of 27 is 3, cube root of 2. Whoops, there should be a cube root there. Okay? So either way works. I'm going to do one more. Let's do the cube root of 750. Okay? Again, I don't even want to mess with my perfect cubes. I just want to go right to tree method. If you want to use perfect cube method, you definitely can. Okay? So if I take 3 out, that would be 250. I don't think I can take 3 out, so I'm going to take 5 out. Smallest number would be 2. Smallest number 5 gives me a prime. Okay? All right, now remember, this is a cube root. So I'm looking for groups of 3. So here would be my group of 3. So they get to come out front. Remember that 1, 5 represents a group of 3. Then this guy and this guy didn't have partners. They didn't have a group of 3, so they have to stay inside. So my final answer is 5 cube root of 6. Remember, that doesn't mean 5 cubed. That means 5 cube root of 6. Okay? All right, now let's switch gears. I'm turning the page to look at page 288. Okay? Now we're working with addition and subtraction. So where before I could just multiply and then find the radical using tree method, I can't do that now. I have to have like radicals. And the first one is fairly easy. They give us 12 cube root of 8 minus cube root of 8 plus 5 square root of 8 plus 9 square root of 8. Okay? Think of this cube root of 8, cube root of 8, square root of 8, square root of 8. Those are like, it's like variables almost, okay? So if this would have been 12x minus x plus 5y plus 9y, you would have even easily said, oh, I need to combine my x's and combine my y's. It's the same way here. You have 12 of these minus 1 of these gives me 11 cube root of 8s. Then you have 5 of these plus 9 of these gives me 14 square root of 8s. Okay? Now, the only thing I can do further here is look at those radicals and say, can they be simplified? Okay? Well, cube root of 8, he's perfect. The cube root of 8 is 2. So now I have this. Square root of 8, maybe you want to tree method him. That's prime. It's a square root, so I want partners. So that would be 14, but then this makes 2 square root of 2. 2 square root of 2. So then I could clean that up even further. 22 plus 28 square root of 2. Again, these cannot be added because he's hooked to this guy. He's saying there are 28 square root of 2's there. Okay? All right? The next one is the square root of 242 plus the square root of 72 minus the square root of 48. Now, at first glance, I would say I can't do anything here because, remember, you had to have like radicals to be able to add or subtract. But if I look closer, it doesn't look like any of these are simplified. So I need to simplify them first to then see if I could add or subtract them. So let's start with 242. If I go ahead and tree method him, there's my partner. 36. Okay. Partner there. So here I have 2 times 3 because I had 2 partners, and then this guy doesn't have a partner. Sorry, that's getting kind of messy. Whoops. Minus. So 2 times 2, square root of 3, 2 sets of 2, and the 3 goes inside. Okay, so now I could look at this and say, first off, let's write this again because it's going to drive me batty. Okay, I've got 11 square root of 2 plus 6 square root of 2 minus 4 square root of 3. So I've got 11 square root of 2's and another 6 square root of 2's. That gives me 17 square root of 2's. I can't subtract here because he's not the same. Okay? All right? Now, they gave us one more there. If you wanted to look at example 3, they did a 4th root. It's the same principle there, so I'm going to let you look at that if you need to, okay? The last piece of this throws in some variables, okay? But it's the same exact thing we've been working on, okay? So I don't want that to wig you out. The first part, and I'm going to go right to B on example 4. They give us the square root of 18, h to the 17th. The square root of 18, h to the 17th. Now, I'm going to simplify this separately. I'm going to simplify square root of 18, and I'm going to simplify h to the 17th, okay? I'm going to use perfect square method on this because I know 9, he's a perfect square, will come out of 18. So that'd be 3 square root of 2. I could tree method him if I wanted to, okay? Then I'm going to think about these 17 h's. Remember, they had to come out in groups of 2. So it's like if mom says, you can go to the party, but you can only go if your brother goes. So you have to go in groups of 2. So if you had 17 siblings, okay, 8 sets of you would be able to come out. Because remember, you're coming out in groups of 2, so 8 times 2, there's 16 of you. But then that one little sister has to stay home because she didn't have a partner. Okay, so I left my 3 and my 2 alone. The 3 was still out front, the 2 was still inside. But then I said that 8 groups of h's could come out and 1 had to stay inside. Now, I want to push this a little bit further, and I want to let's do the cube root of 18, h to the 17th. Now, let's just tree method this guy. 2, 9, 3, 3. I don't have any groups of 3, so he can't simplify as far as number-wise. But let's think about our 17 siblings of the H family. They have to come out in groups of 3. That means 4 groups could come out, because remember, each one of those groups has 3 people in them, okay? 3 H's. So there's 12 right here. And that leaves me with 5 siblings inside that couldn't come. Nope, that was a lie. Sorry. Let me try that again. How about jeepers, Lacey. Okay, so how about 15 could come out? 5 could come out. That would give me 15, and 2 would be left inside. Oh, that poor H family. They almost missed out. A whole group of them almost missed out because of my error. Okay? All right. So the multiplying piece is fairly easy again, but now we're going to go back and we're going to do the addition and subtraction. So let's see here. Let's go the 4th root of 48x plus the 4th root of 3x. This is example 4C if you're looking in the book. Plus the 4th root of 243x. Okay, so we have like radicals, we have like indexes, but we don't have the same thing inside. So we need to see if we can break this down. Okay, so, and we've got 4th roots here. Sorry, I keep getting blurry. So let's go ahead and try to tree method this guy. Okay, now 4th root, so I need groups of 4, which I have it right there. So that's 2 4th root of 3x. Now, let's go ahead and take a look at these x's. Mom says you have to come out in groups of 4. Mom says you can only go to the party if there's 4 of you. Well, poor lonesome little single child here didn't have any siblings. So he doesn't get to go to the party because he doesn't have a group of 4. He has to stay inside. Okay? This guy right here we know is prime, so he can't be tree methoded, and he doesn't have enough siblings to go to the party. So we get to bring him straight down. Okay? 243. Pretty sure he's perfect, guys, but I'll go ahead and show you. Must be 3. Gives me 81. 3 gives me 27, I think. Oh, shoot, dang, he wasn't perfect. Okay, here's my group of 4. So 3, 4th root. This guy doesn't have a partner. We already talked about this little guy. Doesn't have enough siblings. So now, check it out. I have 2 4th root of 3x's plus 1 4th root of 3x plus 3 4th root of 3x. 2 plus 1 plus 3 gives me 6 4th root of 3x's. Okay? So, make sure you get those written down. Ask questions if you need it. See ya.